Testing a normal distribution. We have performed various hypothesis tests before, and we know that the basis of these tests are the hypotheses. H0, the null hypothesis, and H1, the alternative hypothesis. The null hypothesis for this test is that the sample is taken from a population with a particular mean. The assumed population mean is called the hypothesized mean, which is denoted by mu0. So the null hypothesis is that H0 is that the mean is equal to the hypothesized mean. The alternative hypothesis can then take various forms depending on the test undertaken. It might be that mu is greater than the hypothesized mean if we suspect that the mean is greater than the hypothesized mean. It could be that it's less if we suspect the mean is less. Or we might just simply suspect that the mean is different to the hypothesized mean, and we're not sure whether it's less than or greater. So all we now require is a test statistic and a way to identify the critical region. If X follows a normal distribution with mean mu and standard deviation sigma, and therefore variance sigma squared, then the mean of a sample drawn from the population should follow X bar is a normal with mean mu and variance sigma squared over n. The test statistic is as shown here, where X bar is the mean from the sample. Critical values are just determined from the standard normal distribution. That's a normal with mean 0 and standard deviation 1. We can either identify a critical region and determine whether the test statistic is in the critical region or not, or we can look at the probability or p-value of the test statistic and compare it with the significance level. We will look at both in the examples that follow.